Look at this galaxy. Now imagine discovering that most of what controls its motion is completely invisible.
Every star we see, every planet, every cloud of gas, every glowing galaxy is made of matter we can detect. But when astronomers began measuring how galaxies actually move, something didn't make sense. The stars were moving far too fast. According to the matter we could see, some galaxies should not even be able to hold themselves together, yet they do. So what was holding them together? Gravity depends on mass. More mass means stronger gravity. So if the visible matter wasn't enough, there had to be something else, something invisible, something that doesn't shine, something that doesn't seem to absorb or reflect light in the normal way, but whose gravity could still affect the universe. Scientists gave this mysterious substance a name, dark matter, and this was only the beginning of the mystery. The galaxy problem. Imagine throwing a ball around a campfire. The closer you are to the center, the stronger the gravitational pull. You might expect stars far from a galaxy's center to orbit more slowly, but observations showed something strange. Stars near the outer edges of galaxies were still moving incredibly fast, almost as if the galaxy contained a huge amount of invisible mass surrounding it. Astronomers began to think that galaxies might be sitting inside enormous invisible structures called dark matter halos. We couldn't see them, but we could see their gravitational fingerprints. Gravity reveals the invisible. And then came another extraordinary clue. Gravitational lensing. Einstein's theory of general relativity tells us that massive objects can bend space-time, and therefore bend the path of light. So astronomers can look at distant galaxies and observe how their light is distorted. And sometimes, the amount of gravitational distortion is much greater than the visible matter can explain. It's as if something invisible is adding extra gravity. We can't photograph dark matter directly, but we can observe what its gravity does. The cosmic web. The mystery becomes even bigger when we look at the universe on its largest scales. Galaxies aren't scattered randomly. They form enormous structures, long filaments, clusters, and vast cosmic voids. Together, they form something scientists call the cosmic web. Computer simulations show that invisible dark matter can act like a gravitational framework, helping ordinary matter gather into the structures we see today. In other words, the invisible may be helping shape the visible universe. But what is dark matter? And now we reach the most frustrating part. We still don't know exactly what dark matter is. Scientists have proposed different possibilities. Maybe it's made of an undiscovered particle. Maybe it's something completely different from the particles we already know. And perhaps our understanding of gravity itself is incomplete. Scientists are searching for answers using underground detectors, particle experiments, astronomical observations, and powerful computer simulations. But so far, the dark matter particle itself has remained elusive. The bigger mystery. Here's the incredible part. Everything we see in the night sky, stars, planets, galaxies, and even the matter that makes up our own bodies, may represent only a fraction of the matter in the universe. The rest could be hidden in something we cannot see, something we have never directly touched, something we discovered, not by seeing it, but by watching what it does. So the next time you look at a galaxy, remember, the stars you can see may only be the visible surface of something far larger, a hidden cosmic structure stretching through the universe. And perhaps the greatest mystery isn't where is dark matter? It's this: what exactly is the universe hiding from us? To know, subscribe The Journey of Scientific Discoveries. The search continues.